We give free Wi-Fi to some of the cities we're in order to get on some of the buildings.
Yeah.
And we have one we're down in South Carolina, and we have a 5 meg. Right now they have a 5 megabit DSL connection and 512K up, and the Speakeasy, if you go there, the DSL tests 5 megabit down and 512 up. Our service gets 7 down and 3 megs up. But why is there, when you go to a website, there's like a hesitation, and then all of a sudden the pages come in. If we go to the tower where the backhaul is, there is no hesitation. It comes up immediately.
Okay.
But on the DSL, there is no hesitation either, which is the wired connection.
Yeah.
Is there and we're using the NanoStation 5 and let's see, connecting back to the Power Station 5 with a 17 dB connector. It's only about 3 miles away. Our tower has a 12 meg pipe coming, and so it's basically the website. We just want to. They're asking why is that happening?
Yeah, for that one, I would need to really see like an extended time period ping. To see what the ping averages are over, say, a 15 to 20 minute span. And what I want to see is during that ping time, just try and access a web page every once in a while and see what the pings are doing, see if anything's dropping. The only thing that's going to cause hesitation for the most part is interference or poor ACK timing. That one could be a big one. If the ACK timing is borderline, it could take longer to access any web page that you may want to seek out. The other thing could be maybe there's like a multicast or unicast problems where when it's sending these requests out, it might be looping the network a little bit. And so to avoid something like that, you'd want to use AP WDS mode to station WDS mode. So at that point, it's a layer 2 transparent bridge. So then you can roll out any routing problems, anything like that. From there, look at interference on the channels. Maybe some change the channels. Check the RSSI. So look at the noise floor and see what your signal strength is. And then you can calculate the RSSI based off that. If it's like 10 to 15 dB, it might be a little too low. That would also be something to look at. But definitely check ACK timing. That's a big one.
Okay. I figured it could be something big. Can you get 100 clients and some of them using VoIP on a Rocket M?
Yes, absolutely. That's exactly what it's geared for. But to get 100 clients, all those clients have to be AirMax clients.
Right. That's what if we have 3 Rocket M's with 120 degrees sectors, 19 dB sectors, 120 degrees, with 100 clients on each M, and the backhaul. Let's see now, the 1M with a 30 dB dish backhaul. Essentially, with a Rocket backhaul, handle 300 clients, data coming from the 3 access points.
It will, but you will be limited by the Ethernet speeds at that point. So if you're using a single Rocket dish backhaul, you can only get 85 megs in one direction. So, or 150 megs, TCP/IP aggregate throughput, so up and down. If all 3 of those AP towers are stressing it more than 85 megs, it's just going to cap off. It's going to cut the cap at 85. So, but as long as those 300 users are within that 85 meg limit, just surfing the web, it's no problem at all.
He has some 900 megahertz stuff. I'm not going to go into that. A few more questions. He's asking about dual polarity options and using 2 antennas. Will this do anything for us? He said, find out details on dual polarity options and using 2 antennas. And what on the client side would have to be changed. Also, their adaptive antenna polarity.
Now, if you're using all M series, there's no adaptive antenna polarity. M series 2x2 is always using both polarities. It has to have both polarities. If you take one of the polarities out, you're locked into the 1x1 MIMO rates, and whatever antenna you're plugged into is the one it'll communicate with.
On a Rocket M as an AP, should you leave it in bridge mode or set it to router mode? Transio, tech support, told us once if we had more than 20 clients attached to an AP, AP, we should set up in router mode. What do you suggest?
Absolutely, with our units, Rocket M is an AP. If you have 100 clients, absolutely set it into bridge mode. Always have it bridge mode, and then on the back end, always have your router dishing out IP addresses. It makes the network infrastructure cleaner, and there's less of a chance of looping your network and crashing everything down.
Two more questions. Well, maybe three. Explain how to use a line antenna, the Align Antenna tool, RSI range slider option. What is that?
Slide it to the left. It narrows the range that the antenna is looking at. So basically, slide it all the way to the right until you get the signal bars full. Slide it down a little bit, keep adjusting, and then get the signal bars back to full. Slide it down a little bit, do it again, and every time you slide it down, it becomes more of a finite adjustment. So,
okay, that makes sense. Let's explain channel shifting option. Do we need to do anything on the client side?
Channel shifting has to be enabled on both ends. Channel shifting uses the off channels. So normal 802.11 channels is 2412, 2417. Our channel shifting goes 2415. Shoots it right in the middle of there. So when you're using narrow channels, you can get in there and kind of skirt around some of the interference.
Because we have a lot of experience. And then last question. He was testing at Walmart, and we were about a mile away from our tower on top of a mountain. And he was using a NanoStation 5. He was getting a 74 dB signal level, and it was the same 25 dB grid antenna. But with the Power Station 5, he was getting 81 dB. He says, any suggestions? What do is there something wrong? Or?
So we do know for a fact that any nanostations using the SMA port on the external port going to an antenna, there's going to be an inherent loss, RF trace loss, because of the way it's designed in the PCB. So it is in the design. We don't have any plans to fix it for the future because it requires complete overhaul of the devices. If that's the case, swap that nanostation out for a Bullet 5, and you're going to gain quite a bit more signal.
So there was really, the Power Station was probably getting what it should have got. Actually, the NanoStation 5 was a lower.
That's actually what I would expect. I would expect the NanoStation with the grid to be a little bit lower than the Power Station due to that RF power trace loss on the PCB. So you either step up to an even bigger antenna or switch it out for a Bullet and gain more signal.
That's it. Other than the 900 members. I appreciate it.
Thanks for.
You won't expect it. His name is Mike.
I'm Mike too. Good name.
That's Mike too.
Yeah, that's a great name. All right.
Okay, thanks, Mike.
Thanks for coming out, boss.
Sure, thanks.